A unit is just the part of the measurement that tells us what system or standard we're in. There are three main unit systems, and typically we're just using one in chemistry. Those three are English, metric, and then SI. SI actually stands for Standard International. And it's the one that we use in science. So it's this Standard International that we're going to be using in science and in this class. The SI system is typically based on the metric system, so a lot of the units in the SI system are the same as the units in the metric system. Now let's talk about some fundamental units of the SI system. First off is mass. The SI unit for mass is kilogram. A lot of people think it's gram, but it's actually kilogram, and the reason it's kilogram is typically in science when we're weighing things, we're weighing heavier objects, which is why we need a heavier unit like kilograms and not grams. In class we'll be using grams a lot, but I just want to make sure that you know the SI unit for mass is actually kilogram and not gram. Okay, and then the SI unit for length is meter, which is just M. The SI unit for time is seconds. Sometimes it's abbreviated just S. And then finally the SI unit for temperature is Kelvin. Not Kelvin, but Kelvin. And this is abbreviated as K normally. And this is one of those units that's very different than the metric system. As far as temperature goes, the English temperature units are Fahrenheit, as you guys know. The metric unit for temperature is Celsius, and then the SI unit for temperature is Kelvin. There is one equivalence statement that I do want to make sure that you memorize going from the metric to the English unit system, and that's for distance. There are 2.54 centimeters in 1 inch, and I want to make sure that you actually memorize this equivalence statement. Whenever you're reading a measurement, what you want to do is look at the thing that you're measuring with. Let's say it's a ruler. Then I want you to actually look at that ruler. Here's an example of part of a ruler. And I want you to find out what the difference is between the two closest hash marks. In this case, it looks like it's 0.1 difference. So each tick mark means 0.1. So that's 16.1 is right here. 16.2 is right there. 16.3, 16.4, and 16.5. And so this is the best precision that we can get. Whenever we're taking measurements, we always want to go one place after that. So in this case, if we're using this ruler, we want to read out to the hundredths place. So you always want to estimate out to one place past the known. And so the last digit in every single measurement that you read or take should be an estimated digit. Let's take a look at this ruler in a little bit more detail and take a look at A and B. Okay, so A, it looks like it's right at 16.6. So A looks like it's 16.6, but remember, we need to go to the hundredths place. So we need to actually report A as not 16.6, but 16.60. And let's just say this ruler was centimeters. Then we need to make sure and put that unit on there. Now let's go ahead and try B. B looks like 16.5, 16.6, 16.7, between 16.8 and 16.9, so maybe 16.86. And notice this last digit here, I just estimated. You may look at that and say, no, you're crazy, Dr. Shaw, that looks like 16.7 to you. But you only want to go out one place past the known. And for this ruler, it's always going to be to the hundredths place. So every reading we take on this ruler has to be out to the hundredths place. And this would be centimeters. Now let's take a quick look at how you need to read a graduated cylinder. First off, let's talk about where you need to be looking at a graduated cylinder. You always need to be looking eye level at the graduated cylinder, so that'll require you in lab a lot of times to actually bend down to see the level of the water. Make sure that you know that the bottom of the curvature is called the meniscus, and that's always where we're taking our measurement. So if we're going to take this measurement, why don't you pause the video and write down what you think this measurement would be, and then we'll go through this video. I'll go through exactly how you read this. So again, here, the two closest hash marks are 0.1, so 35.1. Actually, no, the two closest hash marks here, the two closest hash marks are the ones place. Each close hash mark denotes 1. So this line is 35. That line there is 36. The next line is 37. And notice each time we're changing at the ones place. So the best precision on this instrument is the ones place, which means that we need to be measuring out or reporting our answer always one place past that. So if we're looking at a blank number line here, this digit right there will always be known, which means that we need to be reporting our numbers out to that place, to the tenths place. So the way you should read this is 36.5 milliliters. And again, notice I went out to the tenths place. So you're always going past, one place past the known. And the known for all of these markings are the ones place. So that's why I went out to the tenths place when reading this. So try not to look at your notes for this example, but I'm using that same ruler, and let's try this for example 1, and then I want to do there for example 2, and how about right here for example number 3. Alright, example 1, it looks like it's going to be, remember that each one of these tick marks is 0.1. So that means I need to be reporting out to the hundredths place on this ruler. So for example 1, I'm going to say 16.15. And you may have written down 16.16 or 16.17. And we have to always keep in mind that it's that last digit that's always estimated. A different person looking at that exact same thing might have a different last digit, and that's okay. Okay, example 2. That's going to be 17.00. Not just 17, not just 17.0, but 17.00. We need to make sure and go out to the hundredths place. And then example number 3 looks like 16.50. Not just 16.5, but again, notice I'm going out to the hundredths place. 16.50. Be very careful when you're taking measurements in class that you're actually using the proper technique, especially with graduated cylinders, and that you're actually going out to the proper number of places. Because typically in labs I'll take off if you have the wrong number of places, if you're reading the instrument wrong. Let's talk really quickly about digital instruments. If you ever have a digital instrument, then you just read off exactly what the LED says. So digital instruments are easy because the digital instrument actually automatically takes into account the estimated digit and shows it for you. So you just need to write down exactly what that digital instrument says. There's no thinking involved or anything. So I have a scale here that I've put on the left. If you're reading that reading on a digital scale, you would just report that as 390 grams. You don't need to add anything to it or take anything away from it. Because it says 390 on the display, we're just going to report it as 390 grams.